So this video is in continuation to the previous video. There I have explained the logic that I'm going to code here. So if you haven't seen that video, I would suggest you to watch that video because then you'll be able to follow up what I code here more easily. Okay, so let's start with the code. For reference, I have pasted the matrix for DOOFISH matrix for n equal to 8. So let's start coding. So first we take the test cases. Okay, so these are the test cases. I've taken all the test cases. Next, the only input I'm getting within the test case is n, so I take that n. Now let's separate out the even ends and the odd ends. So if n mod 2 equal to 1, this is for the odd one, I print boo. That's it. Now I move to the even part, and also I need some answer for 1, so I mention it separately. If n equal to 1, I print hurrah and I print 1. Okay, so I'll have to make it elif here. Okay, so now what we need to do is, now we move to the main part when n is even. So what I mentioned is I need a matrix where I'll be storing the DOOFISH matrix. This is the DOOFISH matrix. So let me initialize it with zeros for I in range n. Append. Okay, so I have initialized the matrix, the DOOFISH matrix with zeros. We'll be filling this matrix. So how are we going to start is we need a list where we'll be storing these values. I've told you we need this 1, 2, 3, 4, 5, 6, 7. This is for n equals to 8. So we need from 1 to n minus 1. So we need a list where we'll be storing we need values from 1 to n minus 1. So this will give me values from 1 to n minus 1. Now what we need to do is we need to fill up this first row separately. We'll be filling up this first row separately. What we'll be doing is for I in range first row, we don't need to fill the first value because we'll be filling these diagonal elements later. So we start from here, we fill this. So what we do is, so the column number is 0, the row number is 0, the column number is from 1 to n minus 1. Okay, so what we do is the row number is 0, the column number is I, and we fill from L I minus 1. Yeah, we do this I minus 1 because if you see this matrix, let me write down this matrix. This is L equals to 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. So you see that for 0, 1, we actually need the 0th element in this list. So the I is 1 at 0, 1, so we need to make it 0, so we subtract 1. Now nothing so tough, so we now move to the pattern finding. We now find the pattern. So for I in range n, okay, we need how are we filling the pattern? So we are filling it from this, like from I equal to 1 to n, not n, we do it 1 to n. So we are filling it from the second row till the last row. And how are we starting? We are first filling this 2, 4, 6, the last elements. So, and we are starting in this list from this element, that is from the second element. So we need to maintain an index. So this is k equals to 1. This represents, this is the counter that represents the elements in this list that we'll be picking up. So k equal to 1 essentially means the second element in this list. So we'll be starting with this one, value 2 and index 1. Okay, so this will be moving in steps of 2, 4, 6. At 6 we need to be careful that if we increment 2 again, so we'll be going out of this list. So if we are at 6, we need to make sure that we come back to this list at 1, and if we are at 7, we come back to 2. Okay, so we need to look at this while incrementing this k. Now what we do is we fill this, then we start filling like this. then we fill this, then we start filling like this, then we fill this, then we start filling like this. Okay, so first what we'll be doing is for every row we'll be filling the last value, and then we'll be filling like this. So what I do is first I try to fill the last value. So last value I fill, okay, sorry, for I last value is -1. You can do if you're doing in Python, or let me make it generalized. So last value is n-1, and what I'll be doing is L of k, the second element. And okay, now one thing that I need to notice here is that I need a temporary variable to store k, because this k will be moving in steps of 2, and at this point now we'll be moving 2 3 4 in steps of 1, like, sorry, we'll be moving like this 2 3 4 5 6 7. If you see, what we have done is we have done 2, then now we are filling 3 4 5 6 7. We have done 4, then we are filling 5 6 7 1. Okay, so we need to store this value of k. So this k just says from where do we start. So we start from k and we fill temp, then we increment temp, okay. So we are filling and we are incrementing temp. Now what we do is now we are filling the remaining entities in the row. So now we will be filling like this. So what we do is for j in range, from where are we filling? We're filling the upper triangle. So what we are doing is from I plus 1, yeah, from I plus 1, because we don't need the principal diagonal. This is if we start from I, we'll be getting this also, so we don't need that. We need from I plus 1 till not the last element, but one before the last element, because we have already filled the last element, so we don't need the last element. So we only go till n-2. Now what we do is we fill I comma j with L equals to temp. Okay, we have filled that. Now we increment temp. Now one thing to notice here is that while incrementing temp, we will be going out of index if we are at this position and we increment it more. So what we need to take care is, if we are at this position, we need to come back to 0th index, that is at this element. So before incrementing one straight away, we need to check something. We need to check if temp is equals to what. If temp equals to we need to see the last element in this list. So what is the index of this? So this array is of size 1 to n. This array stores n-1 entities. So this is size n-1. So last element is at index n-2. So this is n-2. And what I do, if n-2, I don't increment temp, I come back to 0, else I increment temp. So every time we increment temp, we need to be extra careful. If temp equals to n-2, the same thing, we repeat the same thing here. Temp equals to 0, else temp equals to temp, we increment temp. So we are done with these. We are done filling these. We have filled the last element. Now the only thing that is left here is we increment k. So again, while incrementing k, we need to be careful. So what we need to see is, if we are at this position, we go not at the 0th index but at the first index, and if we are at this position, we go at the first index, that is at the 0th index. That is, if we are at this position, we go at the first element. If we are at this position, we go at the second element. So how we do it is, we need to be extra careful while incrementing k, because we are incrementing k in steps of 2. So we need to check it twice. While incrementing temp, we were incrementing it by 1. So we had to check it once. But with k, since we are incrementing it twice, every time we are incrementing it in steps of 2, so we need to check twice before incrementing k. So if k equal to n-3, that is, we are one before the last element. We are here, so we go at k equal to 0, and if k equals to n-2, we go at k equals to 1. Fine. And else, if not at these boundary conditions, we increment k directly. This plus equals to. So this is done. We have filled the upper triangular matrix. Now the thing is that we need to fill the lower triangular matrix. Now there's a relation between the upper triangular matrix and the lower triangular matrix, is that the ij and ji are related in some way. If we add n minus 1 to it, we get to ij, if we add n minus 1, we get the ji value. So this is 1 plus 7, this is 2 plus 7, this is 3 plus 7. Okay, fine. So we'll be trying to code that. We'll be filling the lower triangular matrix of A. So I'm at the right indent. Yeah. For I in range n, for j in range. So I'm filling the lower triangular matrix. I'll be filling the diagonal also. So I do it, what? I do it 0 to I plus 1. Yeah. I need I also, and I especially mention if I equal to j, what is happening? If I equal to j, it is, what am I doing is ij is equals to 2 into n minus 1. Okay, if I equal to j, we directly place 2 into n minus 1 because we have already seen that principal diagonal takes 2 into n minus 1. Else, like now the lower triangular matrix, ij is equals to a ji plus what? Plus n minus 1. Plus n minus 1. Okay, so we have completed the matrix. Now the only thing left is we are printing the matrix. For I in range n, for j, okay, since we are using Python, we can do it straight away. I, okay, this will give me the matrix. The I matrix will print the I matrix. Okay, one more thing, we need to print hurrah as well. For okay, what am I doing? Print hurrah. I think everything is fine. Let's try and run this code. Hope everything goes fine. Oh my god, what's happening? Okay, I need to save this code once. So I've saved it. Okay, it's asking me for input. So if I do two test cases, we check it for 6, working fine. You can check it. We check it for 8, we have already seen, so we do it for 4. Okay, so it's working fine. Let's see more test cases. So we again do 2 for 1. It's hurrah 1 for 2. Now you see for 2 it is giving me list index out of range. So why is this case? So I have specially mentioned 2 here to show you this will give an error if you try to do it for n equal to 2. So there's nothing wrong with the code. The only thing is that for n equals to 2, this L will only be, this L will become, for n equal to 2, this L will become L equal to only single element 1. So when I do k equal to 1 here, this means that the second element of the list L, so we don't have any we don't have the second element in L, we only have a single element. So that is why it will be giving me index out of range. So we can try and fix this and accommodate L equal to 2 here only, but what I'll do is, to make the code simple, what I'll do is I'll specially mention if L equal to 2, what I'll do, if L equal to 2, print hurrah and print the matrix. So what is the matrix for L equal to 2? I guess it is 1 3 and it is 3 2. Yeah, so this is 1, oh, this is 2 3, 1 2 3. What is this? Yeah, this is 1, I guess. So we have 1 2 3 and 1 2 3. Yeah, so we print like this. And now if we save our code, what am I doing? If I save my code and if I try to run it again, so let's give 5. Okay, so we try for 1, it's perfect. 2, it's perfect. 3, it's giving me boo. Let's try for a bigger number. 10, it's giving me a very good list. Let's try for an even bigger number. Let's try for 16. So it's giving me. So this code works fine. I hope you enjoyed this session. If you enjoyed the session, hit the like button, subscribe, share with your friends. Thank you. Bye bye.